The Global Science Voice, Mastering English for International Publication. Introduction. Every new science idea can change our world, but for this to happen, we must share it. Imagine a scientist working late. They finally see the results they hoped for. This new knowledge is special. The scientist wants to tell others. They want to add this to what we know as science. To reach many people, in every country, the best way is to publish in science magazines that use English. These magazines are like doors. They let ideas move between scientists everywhere. But for many good researchers, this is hard. It's not because their ideas are bad or their work is not good. It's hard to tell their ideas in the way these magazines want. Knowing science is one thing. Telling it to people all over the world in a way everyone can understand is different. Science magazines have their own way of writing, their own rules. If these rules are not followed, even great science might be missed, not understood, or not accepted. This can make people feel sad. The good a discovery could do is lost. English is now the main language for science. Most big discoveries are first shared and talked about in English. This happened because of how the world is connected and because scientists need a common language to read each other's work. But to do well in this global science world, you need more than just English words. Science magazines want research shown in a special way. This way makes it clear, believable, and easy for many to understand. They need to be sure your findings are true, that you did your work carefully, and that others can trust what you found. If this special way of writing is not used, your message can be lost. This book is based on a simple but strong idea. To get your science published in English science magazines, you must learn a special way of writing. We call this writing that is formal, objective, and precise. Think of these three words as important tools for your writing. Let's look at what they mean in easy words. First, formal writing. This means using words that are serious and proper, like the important work you do. It shows respect for the people reading and for science itself. It means no slang, no casual jokes, and no strong personal feelings. For example, instead of saying we were very happy about the results, you would say, the results were very important. This keeps your writing serious, showing you know your stuff and that your findings matter. Second, objective writing. This is very important for science. Objective means writing based on facts, proof, and numbers, not on what you think or feel. Your writing should show what your tests found, not how you feel about them. If your numbers do not support a big idea, you must say that. For example, if your test shows a small change, you write about that small change, not a big one you hoped for. Being honest builds trust. When people see your work is objective, they know they can believe your findings. Third, precise writing. This means using exact words and clear sentences so no one is confused. Every word should have a reason to be there. You must be very specific about how you did things, what you measured, and what you found. Not being clear is bad for science. For example, instead of saying we added some liquid, precise writing says we added 10 milliliters of clean water. This exactness is needed because other scientists might want to do your test too. If you are not clear, they cannot. Precise writing makes sure your message is understood exactly as you mean it, no matter who reads it or where they are. When you put these three things together, formal, objective, and precise, you get a strong way to share your science. This style is not just about following rules. It's about making sure your research is understood correctly, your steps are clear for others to follow, and your ideas are backed up by your data. This is what scientists around the world look for. It's the base for science to grow, letting knowledge be shared, checked, and added to by scientists everywhere. This book will help you learn these important skills. We will show you how to use this formal, objective, and precise writing style in every part of your science paper. You will learn how to show your ideas clearly, make readers trust you, and make sure your research has the global effect it should. Our aim is to help you. We want to give you the confidence and tools to share your voice with the world and add your special discoveries to the ongoing story of global science. 1. Writing for science papers. Science writing is like talking to other scientists all over the world. When you have something important to share, you want them to understand it easily. How you write is very important. A science paper is not like a diary or talking to a friend. It's like building a strong bridge to connect your ideas with other people's minds, even if they live in different countries. To make this bridge strong, you need to follow some rules. These rules help make your message clear, believable, and impactful. The main goal of writing for science papers that go to many countries is to build trust. When scientists read your work, they need to be sure that what you say is based on good proof and careful work. They don't care about your personal feelings or what you wish were true. They want to know what you found and how you found it. This is why science writing is different, and why learning it well helps your research get published in good journals everywhere. Let's start with this idea. Being fair and sticking to facts is the most important thing in science writing. This means your writing must be based on facts and things you can see, not on what you personally believe or feel. Imagine you were studying how a new plant food helps plants grow. You might feel very happy about this food and really hope it does amazing things. But in your paper, you can't say things like, "I truly think this food will change farming forever," or "It's clear this food is the best." Instead, you must only say what your test showed. You should write down the exact measurements of how tall the plants grew, how big their leaves were, or how much they produced. You would say, plants that got the new food grew 15% taller on average than the plants that didn't, and this difference was important. The point 5. This is being fair and sticking to facts. It means showing numbers, not opinions. Why is this so important? Because science is built on checking things. Other scientists need to be able to look at your results and agree with what you say, based on the proof you give. If your writing is full of personal thoughts or strong feelings, it makes you seem less trustworthy. It suggests that what you found might be because of your own ideas, not because of what the real numbers show. Journals that publish science from all over the world get papers from scientists with many different backgrounds. Writing in a fair and factual way makes sure your research can be judged on its own quality, no matter what the reader thinks. It means letting the numbers speak for themselves, so everyone can understand and believe them. Think about the story of how we learned the shape of DNA. In 1953, James Watson and Francis Crick wrote a very important paper in a journal called Nature. This paper was short, but showed perfectly how to write in a fair and factual way for science. They didn't fill it with guesses about what their discovery meant for life or say how excited they were. Instead, they showed their model of the double helix. They used X-ray pictures from Rosalind Franklin and Morris Wilkins and chemical facts from Erwin Chargaff to support it. Their words were exact. We noticed that the way we thought the parts fit together right away suggested a way the genetic material could copy itself. This was a factual observation that came straight from their model and the facts they had. Because they wrote so clearly and factually, other scientists everywhere could quickly understand how important their discovery was and start to build on it. The DNA shape was not just an idea, it was a fact they could show, written in a way that invited people to check it and agree. This fair and factual way of writing helped scientists quickly accept and use this basic discovery, making biology and medicine move forward faster. Next, let's talk about being exact. This is the second important part of good science writing. In science, every word counts. There's no room for being unclear or having more than one meaning. You must use exact words and clear sentences so no one is confused. This is especially important when you explain how you did your work. If another scientist wants to do your experiment again to check your findings or use your results for their own work, they need to know exactly what you did. Think about it this way. If you tell someone how to get somewhere, you wouldn't say, "Go down the road a bit, then turn somewhere near the big tree." You would say, "Walk 500 meters south on Elm Street, then turn left at the street called Oak Avenue, which has a big oak tree on the corner." Science writing needs that much detail. Instead of saying, "We added some liquid," you need to say, "We added 10 milliliters of a liquid that was 0.1 molar sodium chloride." Instead of "the cells sat for a while," you should say, "The cells were kept at 37 degrees Celsius in a warm box with 5% CO2 for 24 hours. This exactness makes sure others can repeat your work. Being able to repeat an experiment is a main part of how science works. If others can't do your experiment the same way, your findings are less likely to be believed. Journals that publish science internationally are very strict about this. People who check papers, who are experts in your field, will look very carefully at how you did your work to see if it's detailed enough for them to understand and, if needed, do it themselves. Unclear words can lead to mistakes, which can cause bad follow-up studies and slow down how fast science moves forward. Exactness also applies to your results and what you conclude. When you state a result, it should be as exact as possible. For example, instead of saying, "The medicine seemed to make pain less," you would say, "The medicine reduced reported pain by an average of 2 points on a scale from 0 to 10 to 1. This gives a clear, measurable amount of what the medicine did. Also, what you conclude must be directly supported by the numbers you show. Don't make big claims that go beyond what your proof can support. Being exact with words means being careful not to say your findings are more important than they are or to use words that can mean different things. The third important part is being formal. Science papers are serious documents. This means using a proper academic tone and not using slang, everyday talk, or casual words. You wouldn't use phrases like "you know," "stuff," "a lot of," or short forms like "don't" or "isn't" and "a." Formal science paper. The language should be serious and show respect for the science and the people reading it. Why is being formal important? It shows that you are serious about your research and that you respect the people reading it. It creates a professional feeling that is expected in school and science places. When you write in a formal way, you show yourself as a believable researcher who understands how academic writing should be done. This is very important for publishing in international journals, where people from different cultures might read your work. Following a formal, standard style helps to bring these differences together and make sure your paper is seen as professional and believable by people all over the world. Imagine you are writing about a complicated chemical change. If you use casual words like "so, we mixed this goo with that stuff and hoped for the best," it sounds unprofessional and not serious enough for such a topic. Instead, a formal way would be, "The things that reacted were put together in a controlled place, and the reaction was watched for 48 hours. This uses exact words "things that reacted," "controlled place," "watched," and avoids casual talking. These three important parts, being formal, being fair and factual, and being exact, are not just about how you write. They are basic to making sure science research is honest and has an effect. They work together to make sure your findings are written correctly, understood clearly, and trusted by scientists everywhere. Let's think again about the questions you should ask yourself when you write. First, when I explain how I did my research, am I using words that are so clear and exact that another scientist could do my experiment exactly the same way based on my description? This question is all about being exact. Think about every step of your experiment. Did you say the exact amounts of chemicals? The exact temperature and time for how long things sat? The model and details of any machines you used? The exact way you prepared samples? If any step could be understood in more than one way, you need to make it clear. For example, if you used a product bought from a store, say its name, who made it, and its product number. If you made a new way of doing something, describe it in great detail. This level of clarity is a must for publishing in international journals. People who check papers will look for this to see how careful and repeatable your work is. Second, have I shown my results and conclusions based only on the numbers I collected, or have I let my own ideas or hopes change how I say them? This is the main part of being fair and factual. After you have collected and looked at your numbers, stop and look closely at what you think they mean. Are you saying things that are directly supported by your math and what happened in the experiment? Or are you stretching the proof to fit an idea you already had or a result you wanted? For example, if your numbers show a small effect that wasn't statistically important, you must say it like that. Saying the medicine seemed to work a little when the math shows it wasn't important is not being fair and factual. Stick to what the numbers and what you saw tell you. If your results are surprising, that's okay. Science is about finding out what is, not what we wish was. Third, does the way I am writing sound like it belongs in a formal science journal, or does it sound too casual, personal, or like I'm giving my opinion? This question is about being formal. Read your sentences out loud. Do they sound like you're talking, or like you're writing a scholarly article? Are you using short words? Casual phrases? Are you using I or we too much in a way that sounds like you're telling a story instead of reporting facts? While using I or we is more accepted in some journals now, you should still use it carefully and in a formal way. For example, we saw that as usually okay, but we were really surprised to see that as not. The goal is to sound sure and professional, not like you're just chatting. Learning these main ideas, being formal, being fair and factual, and being exact, is not just about following rules. It's about having a way of thinking that puts clear, honest, and provable communication first. It's about respecting the science process and the scientists all over the world who need correct information to learn new things. These ideas are the base for all good science papers, and they are the key to making sure your voice is heard by scientists everywhere. Understanding these basic ideas of formal, fair, and exact writing is the first step. Now, let's see how these ideas fit into the different parts of a science paper, starting with the very important first part, the abstract. 2. Using English for research. For a very long time, people who study the world have shared what they learn. They build on each other's ideas, like building a big, beautiful church with many stones. Imagine a time when a smart idea from one place might take many years to reach another place. This was often because people wrote about new ideas in different languages. A great discovery might be written in Latin, then changed into French, then maybe into German. Each time it was changed, some of its clearness could be lost, its meaning might shift a little, or mistakes could even be added. Think about Gregor Mendel. He studied pea plants very carefully in the middle of the 1800s. What he learned helped us understand how living things pass traits from parents to children. He wrote about his work in 1866 in a local book. But for almost 35 years, not many people understood how important his work was. One reason was the language. It was hard for other scientists to get his papers. When they were found later and translated, people finally saw how significant his work was. If there had been one common language for science that everyone could easily use, maybe the big changes in understanding life would have started much sooner. This story from the past shows us that how we share our science is as important as the science itself. Today, scientists all over the world use one common language, English. This happened for good reasons, not just because people liked the sound of it. It is very useful for anyone who wants other scientists around the world to see, understand, and use their research. English became the main language for science because of history, money, and how universities work. Big science places, important schools, and popular science books are mostly in places where English is spoken or are often written in English. Meetings, working together, and most science writings are now in English. To be a part of this worldwide talk and to be heard by scientists beyond your close friends or your own country, using English is not just a choice, it is needed. It is like a bridge that connects your lab to scientists everywhere, helping your important findings reach as many people as possible. But just knowing English is not enough. The English spoken every day, or even in other school subjects, is different from the special way of writing needed for science papers that go around the world. Think of it like this: you might know how to drive a car, but to race in a very fast car race, you need special lessons, a very good car, and special skills. Scientific English is that special way of writing. It needs to be serious, fair, and exact. This does not mean making your writing sound hard or using big words just to sound smart. It means making sure your research is shared with the clearest meaning, the most truth, and the most trust. It means creating a clear, strong path for your ideas to reach your readers easily, no matter where they are or who they are. This special scientific English is a tool made very carefully to share difficult facts without confusion or doubt. The first main part of this special language is being serious. When you send a paper to a science book that many people will read, you are entering a place for professional work. A serious tone shows that you respect this place, other scientists, and the careful way science is done. It means not using slang, casual talk, short words like don't worrits, or any words that sound too friendly, or like talking to a friend. Instead, you use full sentences and common words. For example, instead of saying, "We found out the medicine worked really well," a serious way to say it would be, "The results showed that the medicine was very effective." Being serious is not about being stiff, it is about being professional. It tells your readers that you are sharing important work in an important way, which makes your findings seem more believable. When your writing is serious, it shows you are in charge and that your work is important, which makes readers trust what you are saying. It helps show that your work is a valuable addition to what we know, and it deserves to be looked at carefully. The second, and maybe most important, part is being fair. Science is built on proof, on things we can see, measure, and test. It is not about what we personally believe, feel, or think. So scientific writing must be fair. This means sharing facts, numbers, and what we see without adding our own ideas or feelings. Instead of writing, "I was so happy to find out our idea was right," you would say, "The numbers from the test supported the first idea." The focus must always be on the proof. When you write in a fair way, you let the numbers and facts speak for themselves. You are telling what happened in the test or what was seen, not how you felt about it. This distance is very important because it lets readers look at the findings based on the proof, not on your personal excitement or sadness. Being fair makes sure your research stands on its own, judged by its facts and how it was done, rather than being changed by the writer's personal feelings. It is the strong base on which scientific truth is built, allowing others to do your work again and build on it, knowing they are working with honest information. Finally, we come to being exact. In scientific writing, every word counts. Being exact means using the most correct and specific words possible. It means not using unclear words, general ideas, or words that could mean more than one thing. For example, instead of saying, "the sample was heated for some time," an exact statement would be, "the sample was heated at 100 degrees C for 30 minutes. This level of detail is not being too picky. It is very important for others to be able to do your work the same way and understand it clearly. If another scientist cannot understand exactly what you did, they cannot check your results or use your work to learn more. Being exact also means writing sentences clearly. Sentences should be easy to understand, direct, and not confusing, so there is only one way to know what they mean. When your writing is exact, you remove confusion. You make sure your methods are understood perfectly, your results are seen correctly, and your ideas are based on a strong, clear foundation. This careful attention to words directly helps the truth and effect of your research, making it a dependable part of what scientists know around the world. So, why is it so important for someone who wants to share their research with scientists everywhere to use English, even if it's not their first language? It is all about how many people can see it and how much it can help. Science books read by scientists from all over the world read international journals. If your paper is written in your own language, only people who speak that language can read it. By writing in English, you let scientists all over the world see your research. This greatly increases the chances that other scientists will read, mention, and use your work, making science move forward faster. It is about making sure your discoveries help everyone understand things better, not just people in your own area. How does using a serious tone in scientific writing make the research seem more believable and have a bigger effect? A serious tone shows that you are professional and that you take your work seriously. When a reader sees a paper written in a serious, academic style, they understand that it has been checked carefully and is shared with great thought. This builds trust. A serious tone suggests that the writer is sure about their numbers and how they did their work, and they are sharing it in a way that shows respect for other scientists. This confidence, shown through words, can greatly change how the research is seen and how seriously it is taken, leading to a bigger effect in the end. What can happen if you use words that are not exact or are based on personal feelings when sharing scientific findings in English? The results can be quite bad. Words that are not exact can cause people to misunderstand, making it hard for other scientists to do your experiment the same way or understand what you concluded. This can cause your work to be ignored or even thought to be wrong. Words that show personal feelings, by adding your own ideas or emotions, can make your research seem less fair. Readers might question if your findings are true if they think they are influenced by the researcher's personal feelings instead of the facts. In the worst case, words that are not exact or show personal feelings can lead to wrong ideas about the results, possibly causing confusion in the science area or even leading other scientists down the wrong path, slowing down science instead of helping it. Now that we have understood the basic importance of English as the language of science worldwide and the main rules of being serious, fair, and exact, we will now look at the specific parts of this scientific way of writing. Understanding these basic parts will help us use these rules in different parts of a research paper. 3. Publishing in English journals. Science is like a big talk between many people all over the world. They share ideas to learn more. For your work to be part of this talk, other scientists everywhere must understand it. The main language for this talk now is English. Putting your work in English journals that scientists read worldwide is very important. It helps others know about what you found and use it. Imagine you found a new way to grow food that could help many people. You worked hard for years. Your results are very good. If you only write about this in your own language, few people outside your area will read it. Scientists in other countries might not know about your discovery. They might do the same work again without knowing, or they might miss a chance to work with you. But if you share your findings in a well-known international journal, scientists in many countries can read it. They can understand how you did your work. They can check your results. They might even use your ideas in their own places. This is how science is shared with everyone. Sharing your work this way helps you a lot. It makes your work more known. When other scientists read your work in a good journal, they are more likely to mention it in their own papers. When others mention your work, it shows your work is important and has made a difference. This can lead to working with other smart scientists on new projects. It can also help your career. You might get better job offers or get money for your research. Sharing your science with the world makes your ideas bigger and helps everyone learn more. When you write for an international journal, many different people will read it. The people who decide if your paper is good enough, the scientists who check your work carefully, and all the readers who find your work later, they come from different places and have different backgrounds. They might not speak English as their first language. That is why how you write is so important. If your sentences are hard to understand, if you use words that are too casual, or if your meaning is not clear, these readers will find it hard to understand your good research. They might not understand your methods. They might doubt your findings, or they might just stop reading. For this, using formal, objective, and precise language is very helpful. Formal means using serious words, like you would in a professional meeting, not when talking with friends. You should not use slang, short forms like don't or it's, or talk too much about yourself. Objective means you should stick to the facts and what you found. Your writing should be based on your data, not on what you feel. You are sharing what you discovered, not trying to win an argument with feelings. Precise means using the exact right words. Every word should have a clear meaning. Your sentences should be built so there is no doubt what you mean. People should not have to guess. Think about how hard it is to talk when people are from many different places. A word that means one thing in your country might mean something a little different, or even the opposite, somewhere else. A way you build sentences might feel normal to you, but sound strange or confusing to someone from another country. When you write in a formal, objective, and precise way, you create a clear space for everyone to understand. You remove chances of misunderstanding because of different cultures or languages. Your science message, your methods, your data, your findings can then be seen clearly, without confusion. This way of writing makes sure your new ideas can be understood by as many scientists as possible, no matter what language they speak. Choosing the right journal is the first smart step. Every international journal has its own main topic, its own readers, and its own rules. Some journals are for very specific science areas, while others cover many topics. Before you start writing, it is good to look at journals that have research like yours. Read some articles from those journals. See how they are written. What kind of words do they use? How do they show their results? What is the general feeling of the writing? This will show you the style and standards you need to meet. It is like learning the rules of a game before you play. When your writing fits what a journal expects, it has a better chance of being accepted. Carefully picking and understanding a journal's goals and readers is a key part of getting your work ready for scientists all over the world. To do well with international English journals, you must show your research very clearly and professionally. The next parts will explain the main ideas for this important way of writing for science, being formal, objective, and precise. These are the main parts of writing impactful science for the world. 4. Improving English skills for scientists. The path from a science idea in a lab to a published paper in a famous science magazine is long. It needs careful work, checking things closely, and, most importantly, explaining things clearly. Many smart scientists don't speak English as their first language. This makes it hard to share their work. They need to change not just their numbers, but the main idea of their science into a language that people all over the world can understand. So, for scientists, getting better at English is not just about learning new words. It's about learning a special way of talking about their work. This way makes their work not just easy to understand, but truly important. Think about Dr. Anya Sharma. She was a dedicated scientist in India who studied a new kind of enzyme. Her work could change how certain illnesses are treated. Anya spoke English well enough for daily talks, but when she wrote about her science, she struggled. Her sentences felt awkward. Her ideas sometimes didn't seem strong enough. She worried that the beauty and importance of her discoveries were hidden. She sent her paper to a top magazine, but it was sent back. The reason given was that it wasn't clear enough. This made Anya sad, but it also made her want to try harder. She saw that writing science in English for other countries was like learning a special language. She needed to learn its rules to share her science with the world. This is the main point. More than just basic grammar, science writing needs something special. It's easy to think that good science English means only fixing mistakes or learning new words. These are important, but they are just the start. Writing science for the world is like building a strong house. It needs strong parts called formal, clear, and exact science writing. This is not the English of talking with friends or talking about feelings or guessing. It is the English of facts, proof, and clear thinking. Think about saying, "I think the results are pretty good." This is what you feel and is not formal. Now think about saying, "The numbers show a clear improvement in what was measured, and this is proven by math. P.5. This is what is real, exact, and can be checked." The second way says the same thing, but sounds stronger and clearer. Being exact is very important. In science writing, being unclear is bad. Every word must have a purpose. No one should be able to misunderstand. A wrong comma, a word that isn't quite right, or a sentence that is hard to follow can confuse the reader. At worst, it can make them think the wrong thing. How much people trust your science depends on how clear and correct your writing is. If your methods are not clear, how can others do your experiment? If your conclusions are not clear, how can others use your work? This is why learning a special science English is not an extra thing. It is needed to make your science matter to the world. So, what should a scientist like Dr. Sharma, or any scientist who wants their work seen by many, do? This leads us to practicing the right things. What to work on. To get better at science English, you need to improve several key parts. Each part helps make your work clearer and more trusted. First, words are not just about knowing many words. It's about knowing the right words. Science has many special words. Using these words correctly is very important. For example, in biology, knowing the difference between cell breaking and cell dying is key, because they are different things. But it's not just about fancy words. It's also about using normal words with their exact science meaning. For example, important in everyday talk means big. But in math, it means something very specific about chances. Learning to use these words the right way and knowing when to use a special word or a normal word is a vital skill. Next, how sentences are built is how your ideas are put together. Science writing likes sentences that are clear, short, and make sense. This often means not using very long sentences that try to say too much. Instead, breaking big ideas into shorter sentences that connect well makes them easier to read. Think about using I did this versus this was done. Using this was done can be useful in science writing, especially when you want to focus on what happened, not who did it, like the samples were checked instead of we checked the samples. But using it too much can make writing sound far away and less direct. Learning to make sentences in different ways, starting them differently, and making sure each sentence follows the one before it makes reading smoother and more interesting. Verb tense is another part that needs care. The tense of the verb can show different things about your research. For example, you usually use the past tense to talk about the steps you took and the results you got, because these are things that are finished, like the liquid was heated to 50 degrees C. The numbers showed a clear increase. The present tense is often used for things that are always true or known facts, like water boils at 100 degrees C, and for talking about your results in the discussion part, explaining what they mean, like these results suggest a new process. Knowing these rules makes sure your story of the research makes sense in time and logic. Finally, connecting ideas is what makes your writing hold together. This means using words and phrases that link ideas well. These are like bridges that lead your reader from one thought to the next. Words like but, so, also, and because help show how sentences and paragraphs are related. They show contrast, cause, and effect, adding more or order. Without these links, your writing can seem like a list of separate thoughts instead of a flowing argument. Learning to use these links naturally, not in a way that sounds the same over and over, is key to making your science writing smooth and easy to follow. After her first problem, Dr. Sharma started a plan to get better. She knew that just learning general English was not enough. She needed to learn the special needs of science talking. She started by finding what she was not good at. She saw that her sentences were often too long. She also found it hard to find the exact science words. Sometimes she used many words to describe something when one exact word would do. This brings us to how to get better. Using tools, what to use to get better. Luckily, scientists today have many tools to help them improve their English. For words, dictionaries and word finders are very helpful. But for science writing, you need more than regular dictionaries. Special science dictionaries and lists of words for your science area can give you the exact meanings and small differences of special words. A good word finder can help you find other words, but always make sure the word you choose fits the formal, clear style of science writing. Do not use words that sound too casual or like slang. Style guides are also very important for academic writing. Many magazines and science groups follow certain style guides. These guides tell you how to do many things, from how to list your sources to how to make tables and pictures. Most importantly, they give advice on how to use words, making sure your work is always the same and looks professional. Learning the style guide of the magazine you want to publish in is a crucial step. In recent years, grammar checkers and computer tools have gotten much better. These tools can be very helpful in finding spelling mistakes, grammar errors, and even suggesting ways to make your writing better. They can point out awkward sentences or sentences that are repeated too much. But it is very important to remember that these are helpers, not replacements for your own learning and thinking. Computer tools, especially, can sometimes not understand the meaning or suggest changes that are not right for the formal, clear style of science writing. Use them to check first, but always look at their ideas carefully and use your own knowledge of science writing. Perhaps one of the best ways to get better is by reading a lot. Read many important science magazines in your field. Pay attention to how good scientists write their sentences, how they start their topics, how they show their methods, and how they talk about their results. Notice the words they use, the links they make between ideas, and the overall feeling of their writing. This is like being an apprentice in science English. By reading the work of those who have published in other countries, you learn the rules and small details of the language as it is used. You start to get a feeling for what sounds right and clear in science. Dr. Sharma started spending 1 hour each day reading articles from the magazines she wanted to publish in. She read not just for the science ideas, but for the language itself. She kept a notebook where she wrote down new words and phrases. She also wrote down how authors connected their ideas. She also started using a smart grammar checker, which helped her find mistakes she made often in how she built her sentences. But even with the best tools, one important thing is still needed: getting feedback, the value of another person's view. No matter how good you are, it is very hard to find all the mistakes and things to improve. In your own writing, a new view, especially from someone who knows the rules of international science writing, is very valuable. This feedback can come from different places. If you have other writers who speak English as their first language or have published in other countries many times, their ideas are very useful. They can tell you about how to say things, if things are clear, and about small differences in language that you might not see. Your teachers or bosses can also give good feedback, helping you know how to show your research in the best way. Many schools also have writing centers or special help for students and researchers. These can give you one-on-one talks with writing experts. For those who need more help, professional editing services can be a good choice. These services have editors who focus on science papers. They can help make your work perfect to meet the highest international standards. When you get feedback, be open to helpful criticism. The goal is to make your paper and your writing skills better, not to defend what you wrote first. Ask clear questions. Is this sentence easy to understand? Does my idea make sense here? Does this part flow well? Dr. Sharma decided to ask a senior scientist, Dr. Lee, who had published many papers in top magazines. Dr. Lee carefully read her paper. He looked not just for mistakes, but for how clear her ideas were and if she followed the rules of formal, clear, and exact science writing. He showed her where her sentences could be shorter, where a more exact word would be stronger, and where the link between two parts was weak. He also helped her understand what magazine reviewers expect when they look at numbers and what your results mean. This feedback was very important. It was not just about fixing mistakes. It was about learning a new way to think about her writing. To truly answer the question of what are the specific English language problems that scientists face when trying to publish internationally, and how do these problems directly affect how clear and trusted their research results are, we must look beyond simple mistakes. One big problem is the difficulty of showing the complex, detailed nature of science in a way that is perfectly clear. Science ideas are often very detailed, built on what was known before, and need exact meanings. When this complexity is put into a language that is not the scientist's first, there is a risk of making it too simple, losing important details, or, on the other hand, using confusing words that hide the main idea. This directly affects trust because a confused reader cannot fully see how careful the research was. If the methods are described in a way that seems unsure or not exact, reviewers and readers may doubt if the results are reliable. In the same way, If the conclusions are not clearly stated, the importance and impact of the findings are made smaller. How much people trust their research is tied to how clear and exact it is written. A scientist's ability to share their findings correctly and without doubt in English is a direct sign of how trustworthy and potentially impactful their work is. Furthermore, scientists often struggle with what are the special words, sentence ways, and writing styles that are most important for scientists to learn for formal, clear, and exact science writing, and why are these particularly important for sharing science information correctly? The answer is in the way science looks for answers, which needs you to move away from personal opinions and emotional words. For example, always using the past tense when talking about how experiments were done like the cells were kept is critical because it shows these actions are finished, highlighting that the methods were done in a clear way. The present tense is conclusion. You have taken an important step to share your science with the world. This book has given you the tools to tell other scientists about your work. To be successful in good English journals, your research must be important, but it also needs to be easy to understand, trusted, and make a difference. This means writing in a special way that helps people everywhere understand your ideas. This special way of writing has three main parts: formal, clear, and exact. Think of these as the strong legs that hold up your writing. Formal writing is like wearing smart clothes for a big meeting. It shows you respect your readers, the science you do, and the place where you want to publish. Formal writing means using words that are serious and fit for talking about science. It means not using casual talk, slang, or short words like don't. Instead, you pick words that sound professional. Your writing doesn't have to be boring or hard to read. It just needs to show that you are serious and that your research is important. When your writing is formal, people will believe you are presenting your work with the care it needs. Clear writing is next. Science is about facts and proof, not what you feel. Clear writing means talking about the facts and what you found, not your personal thoughts or feelings. When you write clearly, you let the proof speak for itself. This means saying things in a neutral way, talking about what you saw and measured. For example, instead of saying I was so surprised by what happened, you would say the result showed X. This lets the results speak for themselves. Being clear helps people trust what you say because they know it's based on proof, not just your ideas. It lets others look at your work fairly and use it to do more science. Finally, exact writing is the base of good science talk. In science, if something is not clear, people can misunderstand, get things wrong, or make mistakes. Exact writing means using the right words and making sentences that are easy to understand. It means using the best words for science, telling exactly how you did things, and saying clearly what you found. Saying many or a lot is not exact. It's better to say 5 or 10. For example, saying the water got 5 degrees hotter is much better than saying the water got a little hotter. Being exact helps other scientists understand your work fully, do it themselves, and build on what you found. When your sentences are clear, your ideas make sense, and your science is easier to follow and more convincing. These three parts, formal, clear, and exact, work together. Formal writing helps you be clear. Being clear helps people understand your exact findings without any confusion. Together, they make your writing easy to read, trusted, and important. When your writing is formal, clear, and exact, you are building a strong bridge between your science and scientists all over the world. Now you know these ideas, it's time to use them. Writing is a skill, and it gets better with practice. When you write your next paper, think about how to make your words more formal, clear, and exact. Read your work again and ask, are my words formal enough? Am I showing facts without my own ideas? Is what I mean perfectly clear? Ask other scientists for help. Ask them to look for places where you can be more formal, clear, or exact. Reading good science papers from other countries is also a great way to learn. See how good writers put their sentences together, pick their words, and show what they found. Your science can make a big difference. By writing in a formal, clear, and exact way, you help your discoveries reach more people and help science move forward. You make your work more known, find new people to work with, and add to what everyone knows. Learning to write science in English is an investment in your work, your future, and in science itself. Go now, write with clear thoughts and trust yourself. Let your science be heard by people around the world. Thank you for learning with me.